Welcome, everyone. It's always a tremendous pleasure for the physics department each spring, now for past 10 years, to celebrate our Pappalardo Fellowship program by having a symposium at which several of our current fellows speak. And we have that program today. In addition, as we have done in the last few years, we have one of our former fellows and present faculty members to speak. And so Jocelyn Monroe will kick off our celebration of talks this afternoon with her reminiscences of what the fellowship program has meant.
So thank you very much, Ed. And I'd like to first say that I am delighted to make some introductory remarks to today's 10th annual Pappalardo Fellowships in Physics Symposium. It's been a wonderful experience for me, and when I was thinking about what I wanted to talk about today, I want to share with you both some statistics about the program's impact and also from a more personal point of view what it's meant to me. So the Pappalardo Fellowships program, the mission is to sustain a distinguished on-campus postdoctoral fellowship program for the department that identifies, recruits, and supports the most talented and promising young physicists at an early stage of their careers. And this is made possible by the involvement, the generosity, and the encouragement of Neil and Jane. The program typically appoints 3 fellows per year, and I think, for me, one of the really outstanding qualities of the program that's so unique is that the fellows have complete independence in the selection and focus of their research direction within the department, and there's lots of active faculty mentoring and also lots of lunch. That's a very important part, as I'll illustrate later in my remarks. So the program has now been going for 10 years. We have 27 former fellows, 10 current, and 4 incoming, so a total of 41 fellows. So that's, as any high-energy physicist will tell you, enough events to look at the statistics. So the fellows have done research in most areas of physics, and it's sort of remarkable, when I was making this plot, how uniform the distribution is among the different areas between experimentalists and theorists. Over 90% of the alumni are in faculty positions, which is a pretty impressive statistic, roughly 10% of these here at MIT. And the fellows are also in faculty positions all over the country and around the world. It's a pretty diverse group. Of the 41 fellows, they're from or working in 13 countries on 4 continents. Roughly 50% of them are here in the US now. So some examples of the diversity of physics questions from my Pappalardo class. Fellows studied questions ranging from Nitya Kalawaila, looking at where did the Magellanic Clouds come from, to Henriette Elving, studying what we can learn about gravity from topology near a black hole, to Jake Taylor, investigating how reasonable it is to have a commercial quantum computer. As I was looking into this, I was amazed to find that there's a company that's actually selling a quantum computer. Only 128 qubits, but their motto is, yes, you can have one. To more abstract applications, like Mike Miller looking into studying neutrino mass using solar neutrinos at SNO, to Jeff Gore asking questions about what game theory and evolution have in common, to my research topic of, what is the missing 96% of the universe made of. So there's a very diverse, intellectual range of research questions. Another statistic on diversity that I think is very important and meaningful to me is that of the 41 fellows, 34% have been women. And this is, I think, remarkable. This is about twice the percentage of women getting PhDs in physics in the US. This is more than 3 times the percentage of women in physics faculty positions at PhD granting institutions in the US. And if you actually add up the fellows who are now faculty, just under 2% of the women physics faculty in this country at PhD granting institutions have been Pappalardo Fellows. So in a decade, I think that's truly a remarkable impact. So there are lots of ways to measure impact. Another way is to look at refereed publications. So the Pappalardo Fellows have produced over 1,854 refereed publications, which is a pretty large number. If you compare with a list of countries in the world, publications in physics over the last decade, that puts the Pappalardo program at roughly equivalent to the output of Thailand. So we would be 55 out of the 184 countries in the world that have produced publications in physics in the last decade. Another common way to measure impact in my field is H-index. So if you look at an author or a collection of authors' papers, and you count the number of citations to those papers, and you plot citations versus number of papers. The H-index is the point where those two are equal. So it's the number of papers you have that have that many citations. And so this measures both productivity, you have to write a lot of papers to have a high H-index, and scientific impact. Your work has to be highly cited. And so if you add up the H-index for the Pappalardo Fellowship Program over the past 10 years, it's about 82. Now, this number is comparable to Romania over the past decade. And there are some great Romanian physicists. So this is really impressive. You know, Pappalardo Physics Land is number 38 in the world over the past decade of countries producing publications in physics. So this is really high impact. There's also lots of other kinds of publications that the Pappalardo Fellows have produced, writing scientific journalism for The Economist, The American Scientist, Discover Magazine. Fellows have written for MIT's own Tech Talk and the Physics at MIT magazine, and more sort of broader communication through journalism for the Italian Public Radio, from Paolo Robusco, writing a play that was read at the Central Square Theater, Jane Satat, lectures during MIT's independent activities period, and participating in TV programs on science like Nova, 60 Minutes, Jeff Gore on ABC News. The fellows have also earned many awards for their research from National Science Foundation, the NIH, the Department of Energy. There have been a number of presidential early career award winners, as well as DARPA, the Packard Foundation, the MacArthur Genius Prize, the UK's Royal Society. I counted at least 8 different kinds of teaching awards that have been awarded to current and former fellows, and also at least 23 patents, which I was pretty impressed by. So we can certainly all agree that it's a high-impact program. And when I think from a more personal perspective on the impact, what really stands out to me is something I think is so unique about this program is the sense of community. And it starts with Neil and Jane. Inviting the fellows into their home for brunches and weekends with the family is so meaningful, and it creates a community of the fellows, and I think that really has spread to the physics department, and I think that's so unique. And so there's a lot of emphasis in the program of talking about your research with the broader community, not just the scientists that you work with every day, but also your peers and physicists in the department who may be outside of your field. So this starts with the infamous chalk talk, where you have to try to boil your research down to the few basic points that you can write down on a blackboard. I think all the fellows probably know how that guy feels. 2 more technical talks, fellows present their research at the faculty lunch series, at these annual symposia. The fellows get to participate in the Pappalardo Distinguished Lecture Series and interact with amazing speakers who come and talk to the community. And so these interactions, I think, are a big part of what fosters the community in the physics department. And for me, some of the most significant have been from these weekly lunches and monthly dinners that encourage informal interaction between fellows and faculty. So I thought I'd give you kind of an example of what lunch has led to, in my case, for new research connections. So when I came to MIT as a Pappalardo Fellow, what I wanted to work on was looking for new symmetries in the neutrino sector, studying neutrino mass at the Sudbury Neutrino Observatory with Professor Joe Formaggio and former Pappalardo Fellow Mike Miller. And over Pappalardo lunch, maybe a month after I got here, I had a conversation with Peter Fisher, and we started talking about dark matter, and I thought, wow, that's really pretty interesting. And I got interested in making an instrumentation measurement, and over Pappalardo lunch, I was talking with Eric Hudson, who was kind enough to show me what a flange was. So I built a vacuum system, and that measurement kind of led to development of a new kind of detector. I got really interested in, for low background experiments, how low does the background really have to be? And again, at a Pappalardo lunch, I got to talking with Dick Yamamoto, and we hatched an idea for building a detector, and we built it. And over lunch, June Matthews told me about a great facility for characterizing this kind of detector at Los Alamos. And so that was something that I spent about a year on, and results from that work were just presented by an MIT graduate student at the American Physical Society conference last week. And this was all kind of aimed towards a new kind of dark matter experiment, which James Batat is going to tell you about today. This image here is a picture of a particle interacting in this new kind of detector, which Peter Fisher and his colleagues dreamed up. And it's had a lot of involvement from Pappalardo Fellows, from James Batat, former fellow Rob Simcoe has helped us characterize the apparatus. Gabriella Ciola was a driving force behind the work that led to this image of a particle interacting in the detector. And now this detector is installed deep underground in a mine. So this is sort of a serendipitous story of how these kinds of informal interactions led to research connections that really changed the direction of my research. And it was the independence of the program that made this possible. And all of the talking about your research with the broader physics community has a huge impact. And I think, this is my story. I think all of the fellows have stories that are like this, about how the community of the Pappalardo program has really changed their research directions. And so on that note, I'd like to say thank you to Neil and Jane for making this possible. And I'd like to turn it over to the speakers in today's 10th annual symposium. Thank you.
Thank you so much, Jocelyn, for articulating, certainly better than I could, what this program has meant to you as one of the Pappalardo Fellows, and I suspect to the others. I can only echo the importance of the community element. The independence, of course, the fellows appreciate that. That's something that you can get in other postdoctoral programs. But the close involvement with the faculty, and particularly with the community built by the Pappalardos, is unique to this program. Besides, how many other fellowship programs can claim to have an H-index higher than, well, 38th in the world? That's remarkable.